first results, and we had some surprises and the maps of the sky. So the first thing I want to talk about is what is a neutrino? So what is the world made of? The world is made of protons and neutrons and electrons, okay? We all know that. And in the 1930s, it was the dawn of nuclear physics, and they found that things can decay, so that protons and neutrons can switch their identity back and forth in nuclear reactions, and so you can have this process. But when the physicists looked at this process, the experimental results showed that something was missing, okay? And so there was something else coming out. And in 1930, Wolfgang Pauli said that what's coming out is a particle that has no charge, it has almost no mass, and he called it the neutrino. And he said, I've done a terrible thing. I've invented a particle that cannot be detected, okay? But we can detect it, as you'll see. So what is a neutrino? So a neutrino is a partner to the electron. It has no charge. It has almost no mass, okay? It interacts very weakly. It can go through the Earth. It can come out of an exploding star. And so to see it, you have to have really large detectors if you want one of them to show itself. There are many neutrinos left over from the Big Bang, and so it's important, the neutrino, how our universe has evolved to what it is today and how the galaxies formed. So John Updike wrote a poem. Neutrinos, they are very small, they have no charge, they have no mass, they do not interact at all. The Earth is just a silly ball to them, through which they simply pass, like dust maids down a drafty hall, or photons through a sheet of glass. And you can go on and read the rest of it. It's a great poem. Okay, neutrinos have been in the news lately, okay? About a month ago, Kajita-san and Art McDonald won the Nobel Prize for the discovery of neutrino oscillations. And next semester, there'll be a talk by Dr. Leslie Camilleri about what are neutrino oscillations, and it's very interesting. In 2002, Koshiba-san and Ray Davis got the Nobel Prize for detection of cosmic neutrinos. These are low-energy neutrinos, but they were from the cosmos. Fred Reines got the Nobel Prize in '95 for being the first one to actually detect a neutrino. And three of the professors from Nevis Lab, Columbia University, Leon Lederman, Mel Schwartz, and Jack Steinberger, got the Nobel Prize because they figured out how to make beams of neutrinos at accelerators, and they discovered a new type of neutrino called the muon neutrino, which is different from the electron neutrino. Leslie Camilleri will tell you all about that. Recently, on Monday, there was the Breakthrough Prize that was given to 1,300 neutrino physicists. It's $3 million split between these people. Actually, these 7 guys got most of the money. They've labored underground in tunnels and caverns over the last 2 decades to investigate these ghostly denizens of the cosmos, neutrinos. Okay, so what is the world made of? The world is made of protons, neutrons, and electrons, and now neutrinos, we know. There's a couple other particles that we'll be talking about today. One is called a gamma ray, which is a high-energy photon. It, like the neutrino, helps us look at these objects in the astrophysics. And there's a heavy electron called the muon. And so we'll talk a little bit about it. Those will come up, so I thought I should mention them. So let's talk about cosmic rays now. So we know what neutrinos are. So what are cosmic rays? So cosmic rays are high-energy particles from outer space that